Namaskar. Welcome to the second edition of Satya Samvad. Bharat is sure-footedly moving on the path to reclaiming its place as a Vishvaguru. Bharatiyata advocates for a holistic and sustainable approach to life and society, innovation and development rooted in the principles of balance, interconnectedness, and ethical responsibility. Within science and engineering, embracing Bharatiyata and its Dharmic premise means designing technologies and conducting research with mindfulness towards a delicate equilibrium of natural ecosystems. It involves integrating traditional wisdom with modern scientific knowledge to create solutions that harmonize with nature rather than exploit it. One of the most seminal works in this direction and in the world of science from Bharat in the 21st century has been undertaken by Professor R.K. Kotnala. In his invention of the hydroelectric cell, a milestone in the humanitarian movement towards net carbon zero in the world. Professor Kotnala is widely respected in the scientific community for his remarkable achievements across various fields, including solar cells, multiferroics, spintronics, clean energy, environmental sciences, and scientific ethics. He's chairman of the National Accreditation Board for Testing and Calibration Laboratories, the NABL, and Raja Raman Fellow in the Department of Atomic Energy, Government of India. He was a former head of the Environmental Sciences and Biomedical Metrology Division, as well as a chief scientist at the CSIR National Physical Laboratory in New Delhi. He undertook one of the first doctorate research studies on solar cells in the country. And as of today, he has published over 560 research papers with more than 13,000 citations and an H-index of 57. His most path-breaking achievement has been the invention of the hydroelectric cell, which could be regarded as one of the most important creations of the 21st century. Dr. Kotnala hydropowers the path to a better tomorrow with green energy, clean energy, infusing Dharma into every scientific stride, nurturing not just a sustainable future, but a conscientious one. It's a privilege to have you here with us, Professor Kotnala ji. Welcome, sir.
Thank you, Mrittunjoy, for extending a concise and a nice brief about me.
Thank you, sir. So we have been using water to make electricity for a long time. Dams and generators have been around since the late 19th century, thanks to people like William Armstrong and Henry Menier. They all worked on the power of moving water, but now there's a new way to do it. Instead of using the usual mechanical power of water, you have come up with the brilliant idea to use the chemical aspects of the chemical power of water. It is called the hydroelectric cell, and it's a game changer. This invention from Bharat is possibly the most path-breaking invention of this century, especially given its low waste, economical, and environment-friendly aspects. Can you please explain to us how it works and how it's different from the old methods?
Thank you, Mrittunjoy. This hydroelectric cell, which you have been talking, it is the biggest invention of 21st century, which you have also mentioned, in green energy domain, and it is an alternative to solar cell and fuel cell, which are the in the same line. They are for last more than 80 years, and we have come up with this recently. In 2016, the invention was completed, and now we have basically improved it a lot, refined it, the what public needs. The idea is what you said. If we talk about the 19th century, William Armstrong and Henry Menier, they had come with a very brilliant idea that time, exceptional, but not easy, that you have to have a water which you have to basically store in a big reservoir, which is known as a dam. And by the dam, once the water has been filled up to very high heights, it's in general around 300 feet. So for 300 feet of the water, when it is released from the top, so then what is happening, that waterfall, it loses, basically it has to lose its potential energy, which falls on a turbine of a generator, which is kept at the bottom of the hydroelectric dam. And what is happening? The turbine is being pushed by the waterfall, which is said to be from a potential energy. It has been converted into kinetic energy for generator. And once generator starts moving, because we know all that's what is an electric generator, and then it is producing the electricity. And this electricity is there not only at that time, but even today, it is a quite green, friendly, eco-friendly. But the problem with this is that it has got a limited places where you can store that much reservoir, that big reservoir as a dam, and as well as everywhere water cannot be put into the dam for getting the our electricity. So you have to work for a big, large area. Like in India, Tehri Dam is the one of the very, I'll say the very special example. And the water which is now producing the electricity is now at a one place. It has to be distributed. Once it is to be distributed, means transmitted to the places where it is to be used. But on that area where we create, because it is mostly dams are created near the hills and the forest. So it in fact takes a lot of land, and around it also there is some vegetation loss. And moreover, when the electrical transmission has happened, it goes to the far away. Far away means it travels 300 kilometer or 500 kilometer, and we are consuming electricity out of it. It's a very, I'll say, the simple and the better idea, but of course, ingenious idea from the scientist.
Right.
The problem have come up with this. There is a loss of the electricity on a transmission from one place to other, and it is a huge loss. And also, not only the loss, but you have to transmit in a different places where there are the, let's say, hilly area or remote areas where it is not possible to even transmit. That means we need something which can be a decentralized mode of the electricity transmission, and the decentralization mode of the electricity is possible only through hydroelectric cell or any portable energy source. But once we have done that in the hydroelectric cell, the water is not converted from the potential energy to the kinetic energy and then finally to electrical energy, like in case of dam. It is nothing but we are putting the water, and it's a chemical energy initiated the work to dissociate ions on the material surface. And the material which we have strategically developed, innovated, and finally invented, that this can immediately split the water molecule into H plus and OH ion. Once it is split into H plus and OH ion, the material which we have been using in the invention beginning, that is a magnesium ferrite. On a magnesium ferrite, to increase its capability, we have added some lithium into it, lithium oxide. And then what it gives us, this ferrite, which has been especially engineered in such a way that the magnesium ferrite as such has got a spinel structure. So that in a spinel structure, there is a magnesium, then iron, then oxygen, and this little lithium. So what we are doing, we have to replace out of these the oxygen, if we can make it a more deficient in the lattice. So that gives a very good idea that it has become a defective material. And this defective material has got an ability to attract water molecule towards the material which we have developed. It is in a simple pellet form. And after this, what is happening? As soon as the water is falling, the question is, it has dissociated into two ions, H plus OH, by the material. Initially, chemical dissociation, but in that process, H plus ion, which are hopping on the surface of the material, they are trapped inside the nanopores, which we have deliberately created 30% nanopores in the material. It means we have got a magnesium ferrite, which is oxygen deficient and nanoporous. Pores which have been of the order of the 50 nanometer diameter, 20 nanometer, and even higher to that. And in this one, when water from the water molecule, splitting of the water has happened, H plus ion gets trapped inside of that. And those nanopores, which are 30% optimum value, which we have taken, and a high electric field is developed inside just simply by the Gauss theorem. And once high electric field has happened, then any water molecule coming closer to the magnesium ferrite surface, when we pour the water on the surface of the material, then it immediately starts fuzzy dissociating, because the value is of the order of 1000 volt per centimeter electric field developed by this. Because in the nano size, even the few H plus ions are trapped, you get this one. So what we are getting, fuzzy dissociation of the water molecules continuously, and it is releasing H plus and OH ion. Now those are to be collected, separated and collected. So the only idea was, the best idea, we have taken the different permutations like a p-n junction, as Schottky barriers, but finally electrochemical cell was our final idea. And what we did, we put the two electrodes on the opposite faces of magnesium ferrite. One is a zinc, other side is a silver. And from the water molecule split, OH ion goes towards the zinc, which is acting as an anode, and there it forms zinc hydroxide. The zinc hydroxide, once forms, it releases two electrons. Those two electrons will go from the shortest path from zinc to silver on the pellet. I'll show you the pellets also just after my description. And in that process, what is happening, their H plus ion have been already going because of the cathodic nature of the silver which we have used. So H plus ion are now accumulating at the silver cathode, which is an inert cathode. In this process, the two electrons of the zinc which have migrated from zinc to the silver, those two electrons will immediately taken by the H plus ions, and the H and H, 2H nascent hydrogens will result into hydrogen. So what we are getting, in this process, the water is split by the material, and zinc hydroxide is formed on the one side. Sorry. Zinc hydroxide is formed on the zinc surface, and the hydrogen is being generated at the silver electrode. It's a win-win situation that on one side, zinc hydroxide, which is in a nanoparticle, which we have analyzed, found its value, its commercial value is also very high. On the other side, we are getting hydrogen. So this is again a win-win situation. And in this process, because the two electrons have been transferred from the zinc to silver, therefore we get a voltage. Voltage is 0.98 volt, open circuit voltage of the cell. And in the 1 inch square cell, only 1 by 1 inch square cell, today we are getting 180 milliampere current and 0.98 volt. So that way it gives approximately 175 milliwatt in the very small cell. And now, because it's a very, one point is that it is a portable, very lightweight, I'll show you. And also, not only on that side, the other most important part is that India is rich in iron oxide, magnesium carbonate, and also we get a lithium carbonate, which we are using here. In the lab, there is a process how to generate the our nanoporous, oxygen deficient magnesium ferrite. So that is the process which we go through the calcinations, then the centering temperature, high temperature processing is done, and we get the material. Attaching the electrodes, we get the electrical output directly. And because being a light, like a solar cell does what? On a solar cell, there is a PN junction. You put it into the sunlight. In the sunlight, there will be generation. One photon will generate the electron and hole. Electron hole are separated by the PN junction, and then you have got the collection on the front side as a grid pattern. That is again the silver, and on the back contact, ohmic contact is again that silver. But the solar cell has got a very, I'll say the very costly affair to produce solar cell. Here it is not. It can be produced even in a small college or even my garage of the home. This is the way with the processing that solar cell cannot be produced. That's another part. Solar cell has a limitation. Where there is a light, it will work because photon is generating electron hole. In this case, there is no worries. You do it anytime. You put water, whether it's a dark, because there is no need for any light, and as well as there is no need for any of the catalyst use here. Therefore, it's a very important, and everything from India. This invention has been done by myself and Dr. Jyoti Shah. We together did it. She was working for 14 years with me on this problem. We could get this invention within such a long time, even though I have got a very enriched and a long experience in the research of the different materials. Now it's a time when I'll just take few minutes to show you the at least hydroelectric cell. One can see and understand that what it is and what I'm talking about. Yes. If you look at this side, this is a magnesium ferrite. Magnesium ferrite pellet, small one, about 1 inch square. And if you see the any side of it, you will not be able to see the porosity on it. And you cannot see the nanoporous also. So it's a 1 inch square. What we do on this, we attach a zinc as an anode on this. It is a one of this. On the, once it has been attached, I'll show you the full cell, that you can see this full cell. You can see.
Yes, yes.
So this is a front side where the silver pattern, you can see the finger pattern on the top, and on the back side, if you see, it is nothing but a zinc, right? Zinc sheet. Now it is a one hydroelectric cell. It's completely created, fabricated in the lab, right? And not only on this 1 inch, if I show you the 2 inch size, you can see the 2 inch size. It's a 2 inch, 2 by 2 inch cell. Then it's a material, we'll put the electrode on it. Then not only on this, in the lab, we have generated the 3 by 3 inch. On the back side, one can see with the size, one can understand that how big it is. And not only on this, in a lab, we thought its scalability should be there. And this is the 4 by 4 inch size cell one can see, right? But in a lab, it's difficult to produce. It's only we can generate the only few one. And if you look at the other part of it, which we normally say that I'm going to put a water into a glass, I'll take a seal out of it. And this is the water which I'm going to put into it. And on this, if I put if you see this material, I'll just put one drop of water. You can see how quickly it absorbs. So one can imagine that it has got a very high porosity into it. And of course, nanopores. You cannot see visibly if you try on this. And it will not only this, if I put more, it will appear on the backside of it also. But this is the way the nanoporosity can be understood. But ultimately it comes that if I have got this, then can I really show it that it is working? Yes, I can show it. I'll show you the first. If you see, these are the 3 cells.
Right, sir.
3 cells which I have connected in series. And all these 3 cells, when they are in this, so what is happening? You can see these 3 are connected in series, and we have just connected with our this part, the 3 LEDs, 6 LEDs,
right,
and with the like a cathode anode. And on this, you will see that no LED is lighting by now, right? So nothing is on. But if I put this into the water, here is the water. I can show you. I drank the water out of it.
right, sir.
Fine. Then now I'm going to put it into this water.
Right.
You can see all our LEDs are glowing, and it will keep on increasing. On that glass itself, it is inside, and one can see how much light I'm going to have. So it's a spontaneous process. So how electricity is being generated by the 1 inch square, even if I take them out of this water, because it has absorbed enough water, and you can see the glow of the light, how much it is, one can understand, and I'm holding everything with my hands. So this is a hydroelectric cell, and it will continue to glow for at least, with this intensity, slightly more intensity will increase. It will go for approximately 50 minutes with whatever the drops of water it has absorbed into it, right? So this is a hydroelectric cell which has got how much brightness, one can understand, one can see with this visibility, right?
Yes.
This is the only way of showing it. And this makes at least that it is a portable, it is a very light, it can be put anywhere, it can be used like a closed battery. Right? So this is the I have put it here on this. One can see it clearly that what I have been doing it, right? Now we can go ahead. What will you like to move ahead?
Yes. So, sir, I think thank you for the demonstration. I mean, for our viewers, I would like to kind of highlight that this is a commendable and a very ingenious way of looking at how one can use water and the idea of nanoporosity. And the most important thing is that it has a significant electric output. I mean, 0.98 volts is not any less than most of the other kind of technologies out there. And it is economical, it is environment friendly. So I think I would really like to commend you, sir, for this path-breaking work. Also, I would like to kind of contextualize this because there have been efforts to address the global energy crisis. And this has spurred the research into alternative fuel systems. And over the past 4 decades, a lot of attention has been given to hydrogen-based energy economies, fueled by solar or UV irradiation of water. And so, however, challenges like high cost and reliance on electrolytes, irradiation of these devices, challenges such as high cost and reliance on electrolytes and low conversion efficiency have hindered the industrialization of such techniques. And so in this context, how do you see the invention of the hydroelectric cell as being particularly important?
As you have correctly said, that there is a low efficiency. Then moreover, the problem is that whatever we are using, those are all chemically intensive processes for the use of as an electrical I'll say the small power source, or even if you are going for a larger one, then you are going to use thermal power stations where the coal is being burnt, or the diesel is burnt to run it. And if we are going to use the other parts also, then we are using the crude oil. So that makes a big problem, that environment is totally destroyed by our particularly, I'll say, call it a use of fossil fuels. Some of them are very cheap, like wood burning. If we are using the wood burning in our remote areas, villages, there the cost is very low, but for the human health and as well as for the environment, not only the human health, then it comes to our plants, the flora, fauna, both. That is a real big problem. And the most important part is, because in that case, carbon dioxide is being emitted, and even carbon monoxide is being emitted. And it makes a sense that when these are being emitted, we know very well the global warming is happening. And global warming results, everybody is able to see the abrupt change in the weather conditions, not only in India, but all over the world. Like even if you look at the Iceland, in the Iceland, our trillion tons of in the last decade, trillions tons of the ice has been melted because of our global warming. If it is happening, that means there is a problem. Problem says the sudden melting of the ice, this much amount in one place, it is again in the Himalayas, height has decreased because of the melting of the ice on it. Because the global temperature is going beyond the 1.5 degrees C increase in that time. And our particular last year has been, 2023 had been a very bad on it. This global warming has gone maximum to a peak. So that shows that we have to use those energy sources which will not emit any of our global warming gases, which we call it most of the time greenhouse gases. So greenhouse gases, methane also comes into it, NOx also comes into it, but the CO2 is one of the biggest problem, because we are using in the fuels most of the time, we are getting as a output. That is why UN has also moved towards the net carbon zero. That any of the source, any of the activity for the sustainability of the earth, we have to go for net zero carbon. And in that net zero carbon means net zero carbon dioxide. Means if you are emitting, then you balance it out, and so that the net comes out to be zero. Because if you have been using some source, then you must have the another way to mitigate that carbon dioxide, or use it, or convert it into other way, not allow it to get into the atmosphere. So that situation, in case of our hydroelectric cell, it does not emit any greenhouse gas, no toxic gas, no any other kind of problems which normally people face for the environmental pollution. And moreover, when I have used to its life the hydroelectric cell, then I will be definitely either recycling it, and even after recycle, we'll throw it away. So where it will go? It will go into the soil, or it will go into the water. So the not only the environment, we mean that the water and soil also is the polluting, and that we are getting indirectly through the vegetation or through the water in our body. So the human life is at a threat because of this. So, and it is needless to say, it is the case of any of the battery which we are talking about. Lead acid battery, highly problematic in terms of toxicity, lithium ion battery, then the other batteries, cells, button cells. But if we talk about the hydroelectric cell, there is nothing on this side. Even let's say today, one can test it, crush it, and put it into the soil. So it is a nutrient, because soil needs magnesium, iron as a nutrient, mineral, right? And then even the lithium is also, because we are using small amount of lithium carbonate, lithium oxide. So that is also is being used. So and our zinc, if it is put into that side, and it is converted into with the oxygen, with the water, zinc hydroxide in the soil, in the water, then zinc hydroxide is a biocompatible. It is required. Zinc is required. You may be knowing that yes, during the COVID-19, we are using zinc as the one of the strong nutrients with our mineral for our B complex. And not only on that side, when we say that our silver, you know very well, it's an antibacterial. So silver use, if we consume, because I've been using I said the silver, zinc, and the magnesium ferrite. So that way it's e-waste nowhere, means nil e-waste, rather it's a more healthy. And not only it generates electricity, but if I go in a slightly different mode, I am able to generate hydrogen out of it. And another byproduct, which is a zinc hydroxide nanoparticle, again, it's a very costly. So that way, hydroelectric cell, the name we have coined, means me and Dr. Jyoti Shah have coined, the name we have coined, and as well as we had basically invented its working mechanism, principle, and this. And from India, at least we have one device from us, that to energy device, which is very cheap in the sense if I talk about my 1 inch square cell in a lab, it is costing only rupees 15. Wonderful. So one can imagine that how it's cheap at a low cost, and if it goes for a production, then definitely the price will go down. So that way we are having a lot of advantages of it, and rather I'll be very happy when the people will say that, okay, we'll find out some limitation of it, right? But the only one limitation I can say at this stage is that it is inside the lab, it is not in industry. Right. Means that what we need a industrial support for this to go for its production, so that the people can use it.
Sir, I mean, it was so inspiring to know about one among so many other points here, which is the responsible and sustainable manner in which the entire formulation has been undertaken, right from the economic aspect to the ecological and environmental aspects. And most importantly, as our viewers would know, many of the scientific discoveries and inventions that have been done by Indian pioneers in the modern context has often been done in the West, has been done with active collaborations across the world. But this is one of those inventions which have been done entirely in India with a very Indian kind of
Yes.
thinking, so to say. And I would also like to highlight that people from across the world come to Professor Kotnala ji and kind of interact with him, highlighting that whenever he wins the Nobel or certain other recognitions, he should kind of keep them in mind. So I think the immensity or the enormity of this invention will only kind of get more traction as we go along in the years, hopefully. Sir, coming to the idea of magnesium ferrites and the usage of that in devices, you have also made a humidity sensor that's both economically and really good at sensing humidity levels. And it works by measuring the changes in resistance. And we all know that humidity sensors are being used in different things like wearable gadgets, even in agriculture in some of these areas. So how did you come up with the idea for these affordable sensors when it happened?
Dr. Mrittunjoy, you have again put a very right question. In fact, if I, in a simple words, I'll say that the basis of hydroelectric cell is nothing but our humidity sensor.
Right.
In the humidity sensing, work was assigned to Dr. Jyoti Shah for her PhD work, my co-inventor. And on this, because we had used same magnesium ferrite, nanoporous, oxygen deficient, but when it is to be a humidity sensor, then I was not using the electrochemical electrodes on it. I was using just a ohmic contact, silver, no cathode, no anode. And the idea there only we had come that if the water molecule can be dissociated on the surface of my mesoporous, that time we were making a mesoporous, slightly bigger nanopores than what we have achieved in our hydroelectric cell. So mesoporous, oxygen deficient, magnesium ferrite we had used. And from there we moved to the new journey that why not to convert it into our the hydroelectric cell, where the energy generation will be there. And as far as the cost effectiveness, I was always looking for those kind of compounds in which I should have their cost to be very, very low, and we need not to import it, because in import some duty, some taxes also come up. And that is why that time, it is a way back 2004 when we worked on it. And then because when this journey we could change to this way, and it is a very cheap, as I have said today with the electrode, I'm telling you that our hydroelectric cell of the 1 inch square is rupees 15. If I just cut a 1/4 piece of it, even the smaller than that, that will act as a humidity sensor. It is a highly sensitive. We have published a very high level of papers in the international journals on it, that how sensitive we could make it, and with that only we could come to. So it's a highly, I'll say, low cost, and as well as very important. And the idea of ferrites to be used as the sensing material or as our energy material, reason was simple, that if I use any other compound, any other metal, those are having a corrosion, and this is not having because these are already oxides, so they do not get corrode easily, right? And efficiency, when you say that it has become a more efficient than even our sensor, that is why we could publish the paper in that in top journals. It is because of the nanoporosity and oxygen deficiency of the material we engineered.
Right, sir. Absolutely. And again, coming back to the novelty of your work, I mean, your work has been very multidimensional, might I say. So I would like to bring in a little bit of quantum physics here, since that is my area of expertise. And back in 1928, Paul Dirac came up, who is often called the father of quantum physics, came up with this idea of the anomalous electric dipole moment in his very famous paper, The Quantum Theory of the Electron. For our viewers, the electric dipole moment is a measure of the separation of the positive and negative charges within a system. So having myself worked on magnetoelectric effect in multiferroics back in the day, I'm quite fascinated by this important confirmation in one of your studies of electric dipole interactions in BiFeO3 and BaTiO3 multiferroic composites at the atomic level that you had seen for the first time in your joint work with the Banaras Hindu University. So could you please tell us a little bit about the same?
You have truly said that you are working on the quantum physics and you have interest in it, and we have been working on this because multiferroics has been one of the very important material that it will be used for the applications. But a lot of I'll say the thousands of the groups are working all over the world on it even today, but any of the good application has not come out, in spite of the publishing a lot. In that case, when we took up as a way back in 2006 or somewhere, 2005. So when I was working on this, I could realize that they say it's a multiferroic. Multiferroic means it should have the two different properties. So the multiferroic which I have been working, that if my material is multiferroic and I am applying on it magnetic field, then an electric field will be developed into it. And if electric field is present, means if I apply electric field, then it will produce the magnetization in the material. So to work on it, how it is the case, you know very well, barium titanate, bismuth ferrite is being used as a material for this, as a multiferroic, which is a very, I'll say, popular. Idea was that the people talk that it is a multiferroic, it is showing a multiferrocity. I was also working on the material. Then when I was taking its magnetic properties, then I am able to get it. When I am taking its electric properties, I am able to see. But the point is, we want it where it is actually happening. Is it between the electric domains or magnetic domains? Are they interacting? So that was some idea, but it was not clear. And in this case, one of the I'll say the partner who Professor Dhananjay Pandey and myself, we worked on a way that how, because it must be linked with not by the domains, but it is linked with the dipole of the molecules. The molecule which are acting as a dipole, those dipoles which have been generated inside the domains of this. So the magnetic dipole is basically interlinking with the electric dipole. So the electric dipole and magnetic dipole, when they are interlinked, means they are coupled, then only this can happen. So that is why the study, we worked on it. So my expertise was in a magnetic, quite good. And Professor Dhananjay Pandey expertise was in the ferroelectrics, electric dipole, and then the working on the structures. So we combined together the strength, and we could publish a paper in Physical Review Letter, right, which has gotten more than 300 something citations even today. And in this, we could show that the electric dipoles and magnetic dipoles, how they are interacting. So by which way we have to do. So we could see it structurally, we could validate it. Then by the magnetic different temperatures, at different temperature, the magnetic dipoles, how they are behaving. Then we had gone for the differential scanning calorimetry. So these were some of the experiments which could tell us and show that it is working at the at the atomic level. So the atomic level interaction, which is nothing but a quantum physics, and on this we could see it as in totality, like the aggregated effect of it. Because in a material, because we are using the different materials, not a small atom molecules or so. So this comes to I'll say very, very important milestone for the whole world, not for us, because no one had published by that time that the interaction is at our dipoles, atomic level interaction. So that is we can move ahead with this.
Yeah, I think that's a very important result because of what you mentioned, which is that instead of domains, if we come to the level of atoms and to the quantum domain, so to say, and the manner in which these moments themselves can get coupled and how they show an effect is of importance within this study. You have also worked in the area of environmental studies in the context of pollution. Pollution is a real menace as we know it. And most recently in Delhi NCR, we have seen this due to stubble burning in the hinterlands. You have worked on the promotion of quality atmospheric and biomedical measurements for societal and industrial benefits, or PREAS. Besides having published on variations in chemical composition of aerosols during a certain kind of seasons in Delhi itself. So how can we better tackle this problem, according to you, with the urgency that it demands?
As far as the stubble burning is concerned, it is a serious issue, and it is a 3 states involvement into it, because adjoining states are providing this kind of a pollution, because wherever the stubble burning is happening, it is also on the periphery rural areas of the Delhi also, and Punjab, Haryana, and Punjab had been, because the stubble burning was happening more over there. Now, whenever we find a way, because we have to understand fundamental of it, where is the origin of the problem? Origin of the problem is the farmers have to go for change of the one crop to the another crop, because otherwise they cannot get from the same land some yield and some income. So whenever they are doing it, so the time is very short, and within that short period, they have to remove the straws of the already crop which they have basically done. Now the time is less, so for them is the very easy for the farmers. They will say, okay, the one way is you dig your soil of the field, and then digging it and you put it inside. So that's the best way. It will create for you the manure. But why he will do? Because it's a costly affair. Then they don't work, and they have to go for the another crop, growing of the new seeds and this. Then the time is very little. Then they think there is a myth also behind it. Of course, it's not a completely myth, but it's at a lower extent, it is good, correct also, that they will burn the stubble and then they will put it into your field, and it will be more fertile for them. But they forget that while they are burning it, because earlier time it was different, that the bio we have lot of small caterpillars which are basically increasing the soil nutrients. So there are some another bacteria. All those are killed by that fire. So that it means it should not be burnt at all, forgetting about the atmospheric condition. So the farmers are to be taught. They are to be basically made aware of this. That should be the one movement. The other movement should have been from the government, whether if the state is unable to get done this job, then the central should have taken steps that how these stubbles are taken away, because nowadays there are the different agriculture equipments which they can cut within a short period, and then that is taken away, and then how it is to be reused for the other purpose. So that is the only solution. But who will take the responsibility? So even that removal of the stubble can be done in a more methodical way, and also to find out new ways that if some burning has happened, because all people are not aware of it, then how to tackle this. So there is a need for a holistic thought process on it, and deciding that how we can control it.
Right, sir.
Right? Hmm.
And in terms of your recent works, you also have been looking at the healthcare landscape of India as well. I mean, you have been active in this area for a while, and it again relates to the pollution menace in Delhi, but also with respect to COVID-19, which has been quite a problem for humanity the world over. So you have looked at the heightened need for rapid and precise diagnostics, ensuring sustainability in biomedical technology, and particularly with your proficiency in setting up national standards for biomedical instrumentation and calibration. How do you see us fostering Atmanirbharta, which has been such an important aspect and element of our thought in recent times within Bharat, by integrating sustainability principles into this critical dimension of healthcare and biomedicine?
It is a very, I'll say, the very important issue. But what is the real state of our country is that for a biomedical instruments are imported. Most of what we are using, even let's say, which are very common, blood pressure, sugar, diabetic measurements, sugar measurements, how much sugar you have. Then the ECG, then in hospitals I have seen not only ECG, MRI also. So way back 15 years before, I was in AIMS with the director and the Department of Science Technology Secretary. We were there, three. And then I said, no, very important is MRI magnetic field is to be calibrated, because if it is higher, then you are playing with the health of the patient. So that time 5 Tesla was being used. Then later on it has come to 3.5 Tesla magnet, and now 2. But our machine, which is providing the magnetic field, we don't check. It may be correct, but that is needed. So there I initiated MRI. Later on, in the other one, which was in 2015, we took a defibrillator, which is a total risk of a person who has got a heart attack or the cardiac arrest. So revival is done by pumping the charge on the heart. And I have seen in hospitals, the doctors do not have a manual that is how to work and what are the ways for it. So they take their own experience and then they put it. That the defibrillator, 2 pads are put and the charge is pumped, which is approximately 260 joules, or depending on what is the body size and the person. So I decided at that time also to work on a defibrillator as a calibration. And that was done in National Physical Laboratory. And also during that time, I was in a COVID-19, I was an NABL chairman. I had tenure of that. And during that time, I could see the laboratory, there are the very few labs while the COVID-19 was declared, and that epidemic when was initiated in India, then there were no test labs that whether you are corona positive, coronavirus do you have or you don't have. So that time also NABL worked very different way to mobilize the hospitals, even the different industries. So I was supporting it. I was also putting into the field that it can be done. The reason is very simple, that if we are using uncalibrated, which they say quality check, but quality check of the instrument which we are using for the health purpose, which is very critical for every human being. So that is the quality check of the factory, and it is a meaningless, because it must have some standards of this one. So on the standards, I initiated, because there were no single equipment in India related to biomedical, which was important. Not only on this, I initiated with my another scientist, subordinate scientist, even the basmati rice, whose the export was turned back from India by the different countries at the different time. because of the content of the toxic cadmium, arsenic in them, that content. So we developed in National Physical Laboratory with one of the scientists that the standard for the reference material for rice, basmati rice, and as well for the environment, means the air, which we did, and the air, and as well as the for breath alcohol, because where the police is checking that you how much percentage of the alcohol you have consumed. If you have taken more, you should not drive the car, and otherwise challan will happen. So that also did. So there were many, even for the gold standard I did, gold standard I did because my idea was to work for improving the quality without that time I was not a NUBL chairman, but because I was working on the magnetic standards with the lab which I created, and then I was working on it. The health of the people is very important with this one, and there must be a big movement to do it. Now the government has taken some steps that they are going to do it with the different equipment, but the process should have been fast.
Absolutely, sir. The whole idea of calibration and benchmarking of standards across the country is of such importance. And you mentioned in your response about your work with establishing various standards, particularly mentioned about developing the gold and coal certified reference standard materials. So as an academic, you have worked very closely at looking at how academia and industry can be brought together to advance science and technology within Bharat. In the mid-1990s, you established India's first primary standards laboratory for magnetic measurements, focusing on industrial metrology. And thereafter, you have also obviously worked with environmental and biomedical standards. So as a scientist in a growing and blossoming kind of Indian science of Bharatiya Vigyan as we know it today, how do you see us taking academia and industry collaborations forward in a meaningful manner as a nation?
It's academia and industrial interaction should be very strong, but unfortunately we have a weak, not the very strong, but we have a weak links. In fact, as if I have initiated with the lab magnetic standard, I was helping supporting industries, right? But ultimately once they have been supported, after that their way should be with the going ahead to have their research R&D small labs, but they don't do it. They think that the only government labs will do for them, and they will not do it. And even for the industries, they should have promoted more projects on the academia, means whether it's our National Physical Laboratory, or it's a defense laboratory, or it is the IITs, universities. So they should have given the more projects, but unfortunately it's very little. How to do it, in which way it can be done? So I think, depending on the government policy, if it is certain changes are brought in, and as well as the work on this, the industry should know that they can compete with the globally with the help of R&D with them. And that is possible with the industry academia interaction.
Absolutely, sir. I think even within areas of budding interests such as quantum information, artificial intelligence, for instance, in biotechnology as well, I think there has been a lot of interfacing and synergies being established more recently, might I add, between academia and industry. And it is so very important that we continue with this going forward. To bring the discussion around, today we are seeing a new wave of Dharmic resurgence, as we have seen in the recent past. And while we celebrate our civilization's achievements and claim scientific prowess at times from the past, sometimes these claims aren't entirely backed up by scientific evidence. And when we're talking about Dharma in the modern world, one powerful way, as per I see it, is to strengthen it by using science and technology for the dharmic kind of understanding of reality of the universe around us. And I think the hydroelectric cell is a beautiful example of how to use those principles in a very tangible and a very contemporary way, such that everyone can appreciate that in a highly rigorous manner, might I add. So how do you see us taking this forward as a civilization, as a people, and establishing a dharmic understanding, a dharmic resurgence based on science and technology, based on rational thought, and based on things that are meaningful for humanity at large?
It's a really, I'll say, the heavy question where one has to answer.
Yes.
But as a dharmic, we say, or we call it a dharma. So as far as I am concerned, I consider my dharma, my religion, science and technology. And once I consider it, I take it forward and I'm with it. But that does not say that I should not think that there is a universe is controlled by some invisible power, which we normally pray all over the world. So someone is a Christian, someone is Hindu, someone is a Muslim. So they all are doing what? They are praying some superpower. I also believe in that. But that does not mean that I should not work for the science and technology. Because there is always one question on the earth, whether the science came first or the religion came first. It is a big question. Science came first or the religion came first? And it is always a controversial answer. That someone says the religion came first and the science came later. But as far as we look at our system or our plant system, means a human body, there is a lot of science into it. We have learned a lot of technologies have emerged out from the human body itself. That how it is working, there is a pump inside, there is an eye, there's a light. If you talk about, we are able to sense, we are able to speak loudly, amplifier is there in our voice, that we can speak low, slow, there lot of things. And later on, we have brought them as the device in the world. Right? So human being have been already came in, but whether he has to think of the science or the religion. Religion has given us those things. So it's a debatable question. I should not, but definitely I should consider this to be not only me, most of the public should think, without science and technology in the modern time, the life is not easy. So we should consider and we should think the dharma should be in science and technology, most, I'll say, flourishing for the world. And it will bring in sustainability and the good health for the ours and for everybody.
Absolutely, sir. And I think this whole idea of decentralizing the aspect of dharma, the aspect of the reality of the universe, which is seen both in your first response as well, when you're talking about hydroelectricity and how it is decentralized to the individual. And right now, you beautifully put forward how the human body itself has been an inspiration of sorts for various different findings. And I would like to add that I think in Western science as well, be it Albert Einstein or various others, they have been talking about cosmic consciousness. They have been talking about pursuit of truth at various levels. So I think this divide is itself somewhat an artifice of sorts, right? We have to kind of look at the pursuit of truth at various levels. And that's the idea behind this series, Satya Samvad, as well. I would really like to thank Professor Kotnala ji. I think it was a highly enlightening and illuminating discussion today, where we have covered a number of different topics of relevance. I will again like to commend and congratulate him for his seminal work with the hydroelectric cell and the various other multidimensional work that he has done. Thank you, sir, for joining us today.
Dr. Mrittunjoy, I'm really thankful for the your platform also, which has set up the I'll say the intriguing questions and the I'll say the very relevant to the today's time for the sustainability. And so, and I really think that such kind of a discussion interaction should be more with the other people also.
Thank you so much, sir. Thank you. And we'll join you next time. Namaskar.
Namaskar.